Hello everyone, and welcome to this tutorial on using weights and biases, commonly known as WandB. Today, we'll dive into the essentials of performance visualization, model tracking, and hyperparameter tuning with WandB. If you're working on a deep learning project or experimenting with machine learning models, WandB can greatly simplify your workflow. Before we dive into the technical details, let's talk a bit about what WandB is and why it's so useful. WandB is a powerful tool designed to help data scientists and machine learning engineers manage their experiments easily. It provides features like performance visualization, model tracking, and hyperparameter tuning. WandB integrates seamlessly with popular machine learning frameworks like PyTorch, allowing you to log various metrics, visualize them in real time, and compare different trends. This makes it easier to understand how your models are performing and to make data-driven decisions for further improvement. One of the standout features of WandB is its collaborative nature. You can share your projects with team members, making it easy to work on the same project and track all the experiments your team has tried so you never duplicate work. Plus, WandB makes it easy to resume experiments effortlessly in case of runtime crashes. First things first, let's install WandB. Open your Jupyter notebook or use the notebook that's provided for this recitation, and follow along and run the installation command for WandB. Once it's installed, we'll import the necessary libraries including Torch for our model and WandB. Next, we need to set up our device configuration to use a GPU if available. This helps speeding up the training process. After setting up the device, we'll log into WandB using our API key. Make sure you have your API key, which you can find in your WandB account setting. You should go to wandb.ai and click on the user icon on the top right corner and go to user settings. You should be able to find the API key there. Now let's move on loading our dataset. For this tutorial, we are using the CFAR10 dataset. It's a popular dataset for image classification. We will load both the training and the test dataset and apply the necessary transformations to prepare it for our model. With our data ready, it's time to define our neural network. We will create a simple convolutional neural network with few layers. We will not be focusing on this part as this is not very relevant to understanding how to use WandB. Once the model is defined, we can move on to setting up our data loader. Data loaders help us in efficiently loading the data in batches for training and evaluation. Now comes the crucial part, training our model. We will define our optimizer and training functions. The optimizer here is stochastic gradient descent or ADAM, which is as defined in the code. Our training function will iterate over the data in epochs, perform forward and backward passes, calculate losses, and update the model weights. During each epoch, we will log the important metrics like accuracy and loss to WandB. These highly depend on the problem we're trying to solve. If the problem was a regression problem, we'll be loading the mean squared error or the mean absolute percentage error. Logging these metrics to WandB is straightforward. We'll use the wandb.log function to send our metrics to WandB dashboard. This helps in visualizing the training progress and comparing different runs. With everything set up, let's now define our run configuration. This configuration includes parameters like optimizer type, learning rate, batch size, and the number of epochs. These parameters are crucial as they dictate how our model is trained. By organizing them in a configuration dictionary, we can easily adjust and experiment with different settings. It's important to talk about the wandb.init function. The wandb.init function is essential for starting a new WandB run. A run in WandB represents a single execution of a script, typically corresponding to a training session of your model. Initializing a run allows WandB to track and log all the relevant information metrics with the specific execution. Here are the most important parameters of the WandB.init function. The first is the project name. You can specify the project name, which helps in organizing and grouping related runs together. If the project name doesn't exist, WandB will create it for you. The second is run. Giving each run a unique name helps in identifying and distinguishing between different runs. This is very important, especially when you're comparing multiple experiments in the same project. So you might want to give different runs different names, depending on the type of model you're trying to train. Configuration. The configuration parameter allows you to pass in a dictionary containing your run information. This typically involves hyperparameters like learning rate, batch size, number of epochs, and optimizer types. By logging these parameters, WandB makes it easy to reproduce and compare different runs. During training, you can monitor the metrics in real time on the WandB dashboard. This gives you insights into how well your model is performing and helps you make informed decisions about the hyperparameters to choose. One of the powerful features of WandB is the ability to resume previous runs. If your training gets interrupted or you need to continue from a specific point, you can easily resume runs using the run ID. Now that we've discussed how to set up and initialize a run with WandB, let's talk about an equally important step, finishing the run. This is done using WandB.finish function. While it might seem like a simple and optional step, it's crucial in ensuring that our experiments are properly logged and properly saved and uploaded to WandB servers. This includes any final log that might have been logged just before the run ends. Without this step, there might be a risk of incomplete logging. So now let's look at the result of two different runs. So I've decided to change the learning rate from 0.02 to 0.1. And as you can see, the training accuracy for the CNN model with a higher learning rate has increased, while the training loss for the higher learning rate has decreased. So this is just a simple example to illustrate how you can perform hyperparameter tuning using WandB and WandB runs. And next, to work together along with your colleagues, you need to create a team. And to create a team, you need to put in the team name, account type, and invite your team members using their ID or email address. Once you have done that, you're ready to go and share the API key with your team members. So here is a short introduction about WandB, and thank you for your time. I hope you find this helpful.